Okay, so welcome to the second technical lecture for this unit. Um, so far we've covered quite a lot of content already, and as you can see we've got a lot ahead of us, but hopefully you're finding it useful. Twitter is working very well. I'm getting a lot of feedback on that, and a lot of questions are being answered quite quickly because of that. So keep an eye on that feed. If you do have a question, look at that first. So this week we're going to be going over just kind of a short 15-minute block, hopefully, or I intend to anyway, on pixels and resolution, just so you're really clear on the implications of having bad resolution in your final work. I mean, your marks will suffer considerably every semester. And you know, it's quite an unprofessional thing to produce imagery that's of a bad resolution. So we've got to make sure that you really understand the implications of you know, and the consequences of not having an understanding of resolution. It's a hard concept. It's not to follow. So it's probably not the last time that we're going to be touching on it. Second of all, we're going to go over today some photo manipulation techniques and you know, compositing techniques using Photoshop, especially the commands such as selections, cropping, some of the coloring tools, masking, blending, and we'll have an exercise for next week worked out for you on that. So I guess we'll kick it off with a little bit more on raster and vector imagery. More so raster. In about week 4 we're going to be going through vectors when we start to get into vector-based software such as AutoCAD and Illustrator. You know, raster and vector entities are interpreted manifestations, really, of your idea by the computer, and the computer converts that to data. So it's, you know, they're two-dimensional, and they're the building blocks of many of the imagery and the visualization that you're going to pursue. And in this little image at the bottom, you can kind of see in a diagrammatic form the difference. The vector image is made up of a series of lines connected by points. A raster image is made up of a series of dots on a grid. So this here, very quickly, is on the image on the left is a square generated by vector imagery. So very briefly, vector images do not plot on a pixel by pixel basis. So when you have an output, either a screen output for a mobile device or a monitor, or a physical output such as a printer, it's not done pixel by pixel. What happens is the vector files contain a description of the image, and that's expressed mathematically. So it's usually point by point on a Cartesian grid. Essentially, the file will tell the computer about the image, and the computer then draws it. So, you know, you can see here that the rectangle is formulated by drawing from a 0 point 100 units across on the x direction, a line up to an anchor point that's 100 by 100 units off the 0, and then we go left, and in the y direction we go up another 100 points, put another dot, and then that generates the square. Then you also have mathematical information that can attribute a fill to that and a line weight to that. Okay, so we had this slide last week in the technical lecture, but it's a good one just to reiterate a few things. You know that it's the most common form because any output from a digital camera or a scanner usually ends up as a rasterized image or a bitmap image. And, you know, a couple of points, bitmap or raster files plot color values of an image, such as the one at the bottom, in a grid, pixel by pixel. The larger the image, the greater the color depth, the larger the file size though. Now if we just imagine another example, which I don't have a slide for, but it doesn't matter. If you had a grid of, if you had to draw using a raster technique, raster image technique, a circle, that circle will be laid onto the grid. The top of the circle will probably have many white dots, and then the more central ones within the grid representing the circle will have blue. Then you'll have, as you move down the circle, you're going to have less white, more blue. When you kind of get to the middle line across the circle, you'll have lots of blue, a little bit of white on the edge. I guess the great advantage over a vector graphic is that it allows all of these little grid points to have, you know, different bits of information. So each pixel can be ascribed with complexities and subtleties of photographs, you know, of color, of tone, and texture. The advantage of a vector image is that it requires less information to be stored, so you only really have a file size of a few hundred kilobytes with a, you know, a basic CAD drawing, whereas a bitmap image might be a few meg if you want something to be printed. Megabyte, I mean. You know, and again, we've got these, some of the benefits of the raster image. Here's a side-by-side comparison of a raster and a vector. So the image on the left, you've got a series of pixels that make up the image of the axonometric or kind of slightly perspectival sketch of a house. On the right, you've got the vector shape. So all of the lines, or the lines that are generated from point to point information, are then ascribed a bit of information such as line thickness, line color, and also the information, if it's a closed object that you create, say with the one on the right, you can ascribe the fill color. So later in the semester, what we're going to get into is graphic layout software such as InDesign, and we will be able to combine both rasters and vector imagery. This image here is just an example of that. So we've got vector-based line work, which has been generated from a three-dimensional model. It has then been given, all the line work's been given hierarchy and weighting using 2D CAD, and then color information has been added either by vectoral hatches, so the hatching within the shapes, using something like Illustrator, or you can do it in Photoshop, sorry, not Photoshop, AutoCAD, or you can actually overlay blocks of color onto those vector images without losing the vector information. Okay, onto resolution, concepts associated with resolution. Something that you as a student and as a professional must get right. It's the undoing of many students to not understand what resolution is, and when it comes to submissions, submit work of a low quality or low resolution, and consequently the student will get a low mark. You cannot avoid a low mark with a low resolution, badly resolved, badly pixelized submission. So just on the definition of it, it is defined as the number of units that occupy a linear inch in an image. Okay, so if you're working on the intended output of a screen, say an image for a website, you measure it by pixels per inch, because a computer screen is made up of a series of pixels. Or points, they're also known as points. The dots per inch, when you refer to a printer and your output is a printed image, you're working with dots per inch. So the desired print output resolution for a printed document is 300 dots per inch. The desired screen output resolution for something that will appear on a monitor or a smartphone or something is 72 pixels per inch. Here is an image of the bibliothèque at TU Delft, the campus of TU Delft in the Netherlands, by Meccano, just to let you know what this building is. And just using this image, which is 800 pixels by I think approximately 1200 pixels in height, by zooming in on a portion of it, we can start to see that pixel map. So the grid of small pixels that make up the resolution of the image. And if we zoom in a little bit more on that spire, you'll start to see the pixel map in more detail. So I guess, it's trying to clarify what is good resolution, what is of a high resolution, what is of bad resolution or low resolution. Now, if we're talking about printing, and this is an example, this slide is about printing, if you can imagine that these images are 3 inches by 3 inches once they are printed, the top one, which has a pixel grid of 300 dots in an inch, comes through very clear and nice and crisp. The file size in turn is a lot bigger because there's more pixels per inch. The one on the bottom has 72 dots in every inch, which is considerably less dots than the one on the top, and the file size is smaller. However, when you do print it, it's of a worse quality. So a submission that you should be looking for should be nice and crisp, like that one. If you print and your final product's blurry, or it has areas of compression showing, this isn't good. You have to work back and see where you've gone wrong. So by understanding resolution, it should lead to a high quality image in the submission. We're not talking about content here. We're talking about the actual appearance of the page once printed. So just another note on file size really quickly. An A4 sheet at 300 dots per inch. If you have a white document, just a white blank page, the file size is going to be considerably less than something that has many colors, and that goes for monotone too. So if each pixel has to, or if there's a lot of data within all those pixels, the file size gets bigger. So just be aware of that if you're finding that the files are getting huge. So I guess what should be highlighted, is that you can within Photoshop change the size of a digital picture or a digital image and not change the number of pixels. So I'll go through that now. Jump over to Photoshop, and we've got this image here open of Le Corbusier's Unité. Now if I go to Image, up on the top menu, go down to Image Size, you can see, now this is straight out of a digital camera, you can see how many pixels per inch that digital camera has composed the image with. We've got 3000 across, we've got a height of 23, 104 down. The document size, however, that it's translated it to is based on the resolution that the photo was taken at, which is 72 pixels per inch. If I've got this box resample image unchecked, I can change the size of the document and I can change the resolution per inch, and you can see they're all linked, without altering the dimensions or the amount of pixels that are within the image. Okay, so this is changing the size without resampling the image. So if I go in here, so this at the moment it's a little bit over a meter in metric terms, about 80 centimeters high. Okay, and at 72 dots per inch. If we were to print that, it wouldn't be that clear at that size. Okay, and it's probably very rare that you're going to print a picture like this that's a meter big, a meter in width. So just to show you, I've just changed the resolution to 300 pixels per inch. The document size has reduced now, and the amount of pixels that make up the image has stayed constant. And that's a good way to work, I think, because you straight away you're working with an idea that the resolution is 300 pixels per inch, not 72. So you're working within the desired pixel density. So close that, and that's what we've got. And just always get into a habit of saving as well. I can just suggest that to you. Okay, so the next part is on resampling an image. Okay, and most of the time, and how we've worked in the first tutorial, is by downsampling an image that was already too big. Okay, and that's a good way to work. You want to work from a big file down to a small file because we're getting rid of pixels. You don't want to work the other way around where you've got an image that you need to bring up in size, because what that means is that you're going to have rely on the software such as Photoshop to fill the gaps in that pixel map, the pixel grid I should say. So going over here, if we just do the image size command again, and get used to these shortcuts too. Alt Control I will bring up that dialog box. If we click the little resample box at the bottom, now we can actually change how many pixels make up this image. And what that does is it will actually reduce the file size. It also has a tendency, I'm talking about downsampling here, it has a tendency to reduce the document size as well. Okay, and we saw that happen when we dropped things onto the canvas in the last tutorial. So now the first step to do is to probably just demonstrate that if we resample this image downwards, the amount of document, the size of the document gets small. So if I cut that down to 300 pixels instead of 3000, in essence, I'm reducing the file size to 10% of its original, and you can see that also the width of the document, if we were to print it, would go down. So now the documents come from 10 inches in width to 1 inch in width and maintains proportion. If we wanted to keep a nice high print resolution of 300 dots per inch. So just note that for the next bit. So you can see that by downsampling that image, to keep it at a high resolution, we'd have to print it at 1/10 of the size. And we can see that here if we use the zoom tool. So if I press in the top in the options bar, there's a few little key buttons that will help you. That one there is the print size. So the screen tries to mimic the appearance or the size of the document, how it would have to be printed. Sorry, the size of the size you would have to print the document to keep the resolution at 300 dots per inch and keep it clear. And you have to print it very, very small. If we press fit screen, you can see that there are less pixels per inch in the document, and it starts to become pixelized, and this is not what you want to do. You do not want to submit pixelized images. So what I'm going to do is I'm going to do the image size. I'm going to take it down again to 10% of the 300, just to really exaggerate it. You can see the document, if we wanted to have it at a nice print resolution of 300 pixels per inch, you'd have to print it with the size of 0.1 of an inch in width, which is tiny. So to go to print size at 30 pixels and maintain 300 pixels per inch, you would have to print it tiny, like the size of your, smaller than your fingertip. Okay. Now, if we do fit to screen, you can actually see, and what the later editions of Photoshop do, I think CS3, CS5, they will show you the pixel grid as an overlay, like an opaque overlay. So you can see that there's 30 pixels along there and there's 25 high, and we've lost so much information that it's become kind of like this mosaic. Now what I'm going to do is I'm just going to use the history command, make sure you guys know about it, to go backwards. So the history palette within Photoshop lets you go back to an original state. So we can go all the way back to when it was opened. You can see the image has all of a sudden got its data back. But be cautious of this, because that's not saved. If you go and close it, you'll lose, and you've already downsampled, you can't bring back that history, I think, unless you take a snapshot. But I'm not going to test that now. Okay, so going back in the history, we've brought it back to 300 pixels per inch. And to reiterate, let's just downsample to 30. And I'll show you a bad example of upsampling and what you shouldn't do. And you're never going to do it this extreme. You're never going to downsample all the way to 30 pixels and want to come back up 1000%. So I'm just zooming in. Now another way you can see how the scale of something is in the bar here. You can see that the file that I've opened is at 3200% of the actual size of the document. So that's how big this is at 30 by 23. So I'm going to do upsampling, which again you do not want to do. I'm going to upsample it back to 3000 pixels, and now it's at 10 inches. But what Photoshop has to do for us is it has to compensate for the pixels that don't exist. It has to make up all the data to make that document big and of a high resolution. Of course, it has nothing to draw on. There's no raw information. It's not, the camera's still not set up where you originally took the photo, so it can't composite properly. And so it compensates, and you end up with this very blurred image when you upsample. And there's multiple ways that you can upsample. If we go back to image stems, if you wanted to, say, incorporate some kind of mosaic into a design, which I'll show some examples in some of the lectures coming up, you can have it resample or upsample the image back up to 3000 pixels in width and 2300 height by just copying your nearest neighbor. So if we go back up, hit OK, you can see it looks the same on the screen, but if you were to zoom in on the actual pixel map, which you can do, you can see that each one of those blocks of mosaic are made up of, I don't know if you guys can see it on the technical lecture, because sometimes the resolution's a bit low, but there are actually many pixels that make up each one of those mosaic squares. Okay, but that's as clear as you're going to make the image if you upsample from 30 pixels to 3000 pixels. So going back again to the original image, that's my demonstration on resolution. So now I've just got a couple of slides to summarize. Here's a picture of Le Corbusier's hand in Chandigarh. This image is 1200 pixels by 1600 pixels at a resolution of 300 pixels per inch. The document is 4 inches in width by 5 inches in height, or a little bit over. If we downsample to 200 pixels in width, the document size, if you want to maintain 300 pixel per inch resolution in the print, is now 2/3 of an inch in width and 0.9 of an inch in height. And you can see that we've lost a lot of the pixel data if we try to view it on the screen. So if you were to print that and fill it, say upsample, fill the A4 page, you're going to end up with the same thing that's happening on the screen here, where it's all pixelized along the edges. Downsampling to 50 pixels, you can see it gets more severe. Downsample again to 20 pixels, you lose more and more content. So this is the same as what I was showing before. Now when you go to upsampling, so we've gone from 20 to 50, Photoshop tries to compensate and fill the gaps. Go up to 200, it ends up blurred and you lose the subject, so there's a low resolution, bad quality pixelized image right there. And going all the way back up, upsampling to 1200 pixels, and then comparing it to the original, you can see the difference. Okay? So these two slides are actually quite useful as well, because this is just a representation of what's happening on the screen, and you can see at the top that we've zoomed in on the document 3200%. The actual size of it at 100% is tiny, it's that big. So just a couple of points. Your image quality and your resolution of your images will suffer if you ask Photoshop to make up dots that were not there in the original image. So upsampling is bad. If you ask Photoshop to reduce the amount of dots without reducing the real world size of the image, or you ask Photoshop to increase the real world size of the image without having enough density of pixels. So when using these raster images, although they're infinitely manipulable, they have a lot of good qualities, you just got to make sure that you plan ahead. You begin with enough resolution with all images that you can scale down, always downsample, and save the original if you do ever need to come back up, so you can retrieve the information or the data later from a raw file format.